Well, hello everyone. I've been advised to wait till about 1 minute after to give people time to continue to file into the broadcast, so I'm gonna sit tight. All right, I've given it about a minute, so I guess I will go ahead and get started. My name is Michael Klett. I'm one of the co-owners of Mad Cow Rocketry, and I am happy to be here with you today. It's still morning here in California, so I'll say good morning, but for most of you in the country, it's now afternoon. So for you, I'll say good afternoon as well. So just some housekeeping. Over on the right side of your screen should be a chat button if you want to talk to somebody that's here attending. Feel free to go ahead and use that chat button to talk to people. And if you want to ask me a question, I guess you guys are muted, and the easiest way for you to do that is the Q&A button. So I am monitoring the Q&A box, and if I see any questions pop up, I'll be sure to answer them. I enjoy lots of questions. That's what makes this fun. So Mad Cow Rocketry started quite a few years ago now, and the goal of Mad Cow Rocketry was to provide a vehicle for those model flyers that wanted to step up to something bigger than the typical model rocket. And that's been our forte, and we still have a lot of people that are crossing over from flying what I would call model rockets to mid-power, and of course, we as a company have expanded into high power as well. I am a level 2 certified flyer. One of these days I'm going to get my L3, but I haven't gotten there yet. But a lot of us started out flying little model rockets, much like this one. And as we get into trying to make the transition to a bigger rocket, there are questions that come up. So your model rockets, like the one I just showed, typically have a black powered motor that looks something like this. This happens to be an E12-6. And when you build your model rocket, you get a motor tube that looks like this. And when we put the motor in, there's really nothing. I should hold it up here so you can see it. There's really nothing that prevents it from sliding out either end. And so when we're flying rockets, we have to worry about that because on the way up, we put the igniter in the ignition hole. We light the motor, and flames start shooting out. We start thrusting out the back end of the rocket, which is going to push upwards. So what we do is, with the motor tube is we take something like this, a little motor block, and we'll put that down inside of the motor tube, like so that now there's this thing stopping it. So when I push in the motor now, it can only go in that far, and from then on, it's going to push the rocket up for thrusting. Now at apogee, at the peak of flight, we have another event that's going to happen, and the ejection charge is going off if we've timed everything right. And so we're going to have this shotgun blast coming out of the top end of the motor to blow the nose cone off, get the laundry out, so to speak. And if we don't retain the motor there, the motor is just going to shoot out the back end of the rocket and not accomplish the goal that we want. So we have this thing we call an engine hook, try to make it where you can see it. And the engine hook basically gets mounted on in such a way as to be able to hold the motor in place so that now when we have the ejection charge go off, the motor's captive, the blast goes out the top end of the motor, we get the nose cone off, get the parachute out, we come back down safely. And then since we want to fly it again, the engine hook is designed in such a way, I've got it a little too far in, but we bend the engine hook out of the way, we remove the spent motor, we go ahead and repack the wadding and the parachute, put another motor in, another igniter, and we're good to go. But when we start moving into the high power style motors, not necessarily a high power motor, but high power style motors, they look something like this. This is just a 38 millimeter. And you know, so it's a little bit bigger than the model rocket motor. There are some smaller ones, some Econojets and whatnot that are comparable size to an E. This one, like I said, happens to be a 38 millimeter. But all of the high power motors have a unique feature, or a feature that makes them different than the model motor, and that is that at the back end is this aft thrust ring. And that's what makes high power motors a little different than a low power motor, or I should say a high power style. So this is a 38 millimeter motor tube. And if I drop this in, what you'll see happens is the motor can only go in so far because that thrust ring is up against the motor tube. So as the motor is thrusting, we have no issue. The motor is going to thrust, and that thrust ring is going to push on the motor tube. The motor tube is going to push the rest of the rocket, and we go up. So I don't need an engine block in my tube in order to take care of thrusting. I still have the problem, though, at the peak of flight, at apogee, when I have the ejection charge go off out of the end of the motor tube up into the rocket to push the laundry out. I still have to captivate the motor because it could slide out. In fact, if I don't have any retention after the motor starts thrusting, accelerate or continue to coast rather, and the motor will just fall out like so. So we have to captivate the motor at that aft thrust ring for the event at apogee to get the parachute up. So I went to my my build pile. I have quite a few projects that are on their way. And let me show you the whole rocket. So the whole rocket, so it's a nice little rocket. It's a 38 millimeter motor mount. What I care about right now is the fin can. So let me separate it. So on this particular build, I'm using an Aeropak retainer. And the nice thing about the Airpack Retainer is it's real easy to work with. So you unscrew the back of it. So this is the retainer. You drop the motor in, and it gets stuck just like it did when we were putting it into a motor tube. Now, and then we screw this cap on, nice and easy. And now the motor can't come out when the parachute charge, the ejection charge goes off, and it doesn't go through the rocket when we're thrusting. So it's nicely captured. I do want to show you another retainer. Aeropak retainers can be expensive. Mad Cow sells our own retainer, and it's really quite simple and works really well. But basically we have, and it works well for wood aft centering rings. Maybe not so good for fiberglass. But you wind up, the business part is this oval piece, and we have a hole for the motor, and we have the holes for mounting. So use this as a template. You make two holes. We have these nuts that you thread down into the wood centering ring, and then you would put this over the top of it and put the bolts in, thread it down, and tighten it up, and it captures the motor the same way. So the motor tube and this little device here will capture the motor for both the up and the down. So that's the thing that a lot of people seem to get confused with when they're building their first high power style rocket, is how you captivate the motor. They're looking for, how do you do it? You need to buy a motor retainer, and that will take care of it. Since we're talking about making the step from a low power type rocket to a higher power style rocket, when I first started flying, I used to use 3 or 4 sheets of recovery wadding in my cardboard rocket, and those worked great. And then I started talking to other flyers, and I started using 1 sheet of recovery wadding because it was a little bit expensive. And I started buying bags of what is known as dog barf. It's really just cellulose insulation. And I would drop some of that down in on top of the recovery wadding, blow it down to the motor, put my chute in, and go off and fly. So this was a nice way of reducing the expenses just a little bit when I'm flying. But if you start getting into rockets that are this size and larger, it starts requiring, well, first off, that recovery wadding sheet is just not big enough to handle that big of a hole. And then you start using gobs and gobs of this dog barf. And so it starts getting a little bit cost prohibitive, perhaps. So what we switch over to is a Nomex chute protector. So Mad Cow makes and sells these Nomex chute protectors. The nice thing is they're reusable. They're flame retardant. One of the things you'll notice about them is there's this little buttonhole. And so you thread your shock cord through that little buttonhole. And so one side is down towards the fin can and one side is up towards the nose cone. And then you take your parachute and you basically put it down in your recovery wadding. You protect the nylon parachute from that shotgun blast, and then you can shove it down into the rocket, and that'll protect the chute for the ejection event. So nice and easy, nice and reusable, many, many flights out of one of these, and it's a lot easier to use than recovery wadding or dog barf or whatever you want to use. Another question that we often get is when you build a lot of our kits to have a payload section, we tell you to put a bulk plate covering the coupler. And people ask the question, well, if I put the bulk plate on the coupler, how do the ejection gas charges get from the motor up to being able to blow the nose cone off? And so I wanted to talk about that as well. So when you start flying with a payload section like this one has, now I'm actually setting this one up to be dual deploy. So I have a switch span on my coupler, and I have I have eye bolts on both ends. But imagine that I didn't have that and I just had a bulk plate on the end of the coupler. The ejection charges would not be able to get from the motor all the way up to the nose cone because it's going to be blocked by that bulk plate right here. So the answer is we don't try to get the nose cone off. We're going to separate the rocket at the coupler. So if I wanted to fly this one single deploy, I would put my parachute in the fin can, not up in the payload by the nose cone. And so at apogee, I would eject this part of the rocket and separate it into the two halves like so. Now, one thing you do have to worry about, be careful about, is when you are going to fly it single deploy like that, what is going to keep the nose cone on when you eject this section? So you don't want the nose cone coming off and falling down and hurting somebody. So you have to come up with a mechanism of attaching the nose cone to the payload section. So you could, if you never want to fly it dual deploy, you could simply epoxy them together. That would work just fine. If you wanted to be able to take it apart later, perhaps you wanted to put a payload in the payload section, a scientific instrument of some kind, you wanted to be able to do that, then perhaps screws or rivets from the airframe into the nose cone would be the way to go, so that when you hit the hit peak, when you hit apogee and you eject the nose cone, you don't have a problem with the nose cone coming off. But in this case, I'm setting it up to be dual deploy, so I will wind up putting an altimeter into this section here, and then I will use the push out the drogue out the bottom end, open up the fin can and this section, and then about 1,000 feet, when I'm ready to slow down the descent to somewhere around 20 feet per second, I'll push off this section again. The nose cone will stay attached. I'm not going to try to push the nose cone off. I want to separate here. But you could, I suppose, leave this together and epoxy this on like so, and then separate the nose cone out and push the nose cone off in a traditional manner. Okay, so that was the end of what I had to present. I do have a question. Okay. So the question is, I understand a forward engine block. So thank you, Stephen, for the question. I understand a forward engine block or thrust ring is not necessary for mid-power, high power because of the built-in ring on the engine. But is there an issue if one is present? I see lots of people omitting them to allow for greater engine selection. Well, I'm trying to understand how you would. So if you had an engine block in there, so if I come back to my motor tube, if I have an engine block, then yes, it's going to stop the motor from going forward at wherever I put that engine block. And that's okay. I mean, as long as my engine is shorter enough to be able to fit and I can still capture that aft thrust ring, that's good. But I still have an issue with perhaps how I capture the back end. I don't know. So if I want to use the thrust block with a motor that is obviously bigger than this one, but that is just a cylinder, the motor block would stop any motor going in, but trying to capture the motor with an engine hook or the other retainer, like this retainer, the Aeropak retainer, it requires it to be the size that it does so that I can actually capture it. I haven't seen an instance where somebody put a motor block in with like an Aeropak or Mad Cow retainer. I suppose it's possible, but generally most rockets, at least my experience, I've never thought about it. So I apologize for wandering all over in my answer. Most rockets I build to fly either with a high power style motor or a model type motor like this one. I still love to fly models. This was one I built not too long ago. I haven't flown it yet in these days of COVID. But yeah, generally high power, we don't use a thrust block just because, sometimes we want to fly 1 grain or we want to go 2 grain, which is twice as long, or 3 grains. So the length varies a lot. So I would, if I'm going to use a high power thrust, I'm going a high power style motor. I won't put the engine block in. Okay. Let's see. Another question. Okay. Can you describe in more detail how the Mad Cow motor retainer works? Any advantages to it or with clips? Well, so let me pull up my Mad Cow retainer. Okay, so if I were to thread this together, I don't have one drilled in front of me. I dropped a bolt. Sorry about that. Okay. So in essence, the Mad Cow retainer winds up operating about like this. So you can see the oval. We've got the threaded bolts. So these nuts, the bolts thread into these nuts here. So these nuts have to be fixed. And if I can, I don't know how close I can get to the camera and have it be visible. But you can see if you drill a hole, this threads down in to the wood. And so it sits there at the back of the motor. You would drop the motor in, and then you would slide this oval down over the motor to capture it. So you need the exhaust nozzle to fit inside the ring. So that's one of the things you want to pay attention to. So this is designed for, I think it's a 29 mil small, can't think of the word, but the aft end of the motor, there's the exhaust port. So you have to have that come out. So screw these nuts down into the wood, and then you tighten the bolts down as far as they need to be tightened down so that you've physically captured it. So it's just kind of a little clamp. There are lots of other things that I've seen people do. I saw one, it was a cluster motor, and instead of using a clamp this clamp, there was a hole with a nut, and then they used a big fender washer down over the center to capture all 4 motors at the same time. So I don't know if I've answered your question, Sean. If you have more questions about that, let's see what else we have. And Thomas, thank you for your answer. Yeah, no thrust block allows you to use 1, 2, 3, 4 grain casings. They all have different lengths. Kevin asks, how do you retain an engine when you are building a minimum diameter rocket? Great question. I built a minimum diameter rocket, and I used a slim Aeropak style of retainer because I wasn't trying for an altitude record. But what I had to do then was I had to put extension blocks underneath my rail buttons to get them far enough away from the airframe to be able to allow that retainer to clear the launch rail. But Aeropak makes a wonderful product and call for a minimum diameter rockets. So if I were making a 38 millimeter minimum diameter rocket, I would have my motor. So my airframe would be 38 millimeter. My motor would be 38 millimeter. It would slide in, and and you can see that it's nice and clean, so I don't have to worry about anything going on here. But I still have to worry about how I'm going to retain the motor. And the only way to grab the motor is going to be up in here. So Aeropak makes a minimum diameter retainer that you epoxy into the airframe at the right distance, and it has a threaded bolt on it, and your motor has a threaded bolt on it. Actually, one is a nut, one is a bolt, but I have to go check and see which is which. And so you would put it in a certain way. Your hardware would then connect, and then you would have to screw the motor onto that retaining device that's up inside the airframe. Now, you can imagine that the motor that you use and where that retainer is epoxied inside the airframe have to match. The lengths have to match, because if you epoxy it too far down, your motor is going to stick out. If you epoxy it too far up, your motor won't be able to be captured by it. So that means if you build it for a 1 grain motor, you're only going to fly 1 grain motors and so on. But Aeropak has also come up with a device, basically an extension that's the length of a motor grain, so that you can actually glue in that minimum diameter retainer at, say, 2 or 3 grains length into the tube, and then you can fly on, say, a 3 grain motor, just easy as can be. If you want to go to a 2 grain, you screw one extension on, and then you come in, and so you basically have this extension taking the place of the 2nd grain. Okay, so hopefully I answered that question. Is the Mad Cow retainer light? Phil asks, is the Mad Cow retainer lighter than the Aeropak one? Yeah, I think it is. But they're both pretty light. One's made of aluminum. So the Airpack is made of aluminum. Our flashing is made of stainless steel, and you got the bolts and some other stuff. So this is not aluminum. This is. So I think the Mad Cow is still lighter, but I would have to weigh them. Okay. So Jeff asks, for the same size rocket and weight, although a little bit lower powered with 29 millimeter engines, what size Kevlar tether would you use? And is Kevlar a shock cord, or what takes up the shock? Yeah, so I like to use Kevlar. I'd have to go look. I use, for up to about 3 inch, I've been known to use about 1/8 inch, I think about 1/8 inch Kevlar. Eventually at 4 inch and larger, I start going to like 1/2 inch Kevlar or 5/16 just to get a little bit beefier. Kevlar, it has no shock absorption. So good question. Good thing to think about. So with the Kevlar, when you eject the nose cone at the end of the travel, the nose cone and fin can are going to come to an immediate stop. And You know, it's like they say, if you fall off of a building, it's not the fall that kills you, it's the sudden stop at the bottom. And so we have to worry about that sudden stop with the shock cord. And that's the point of the shock cord, is to decelerate and give some stretch so that it's a deceleration rather than a hard impact when you hit the end of the shock cord. So there's two ways to do it. What I like to do is a short piece of Kevlar that gets me from where the attachment point down by the motor out of the fin can. So if I were using this particular rocket, I will use a piece of Kevlar that is from about here to about here. I just want to protect it while it's down in the fin can. So that much Kevlar shock cord. And then I will tie a nylon shock cord onto the end of that and make that very long, so that when I eject open it up at apogee, the nylon shock cord can actually absorb that jarring impact and give a little stretch, because the Kevlar won't. Another thing that I've heard done, and I have not tried it yet, but I love the idea, and that would be to fold your shock cord up kind of accordion style and wrap each accordion bend with tape. And then the idea is, when you eject the nose cone off, the power of the ejection charge, as that nose cone is pushed away from the fin can, you start tearing the tape, and it's the tearing of the tape that is slowing down the nose cone as it's getting towards the end. And if you do it well, the last one or two accordion folds won't actually be broken, and it will have slowed down nice and gradually. Any hints, cautions regarding adhesive attachment of non-screw secured engine retainers? So I'm assuming you're talking about the Aeropak retainer. So this particular one is epoxied onto the motor tube. Give you an example of that. So my 38 millimeter motor tube, again, I have an Aeropak retainer, and it just slides on. So it's not attached with any screws, it's just attached on. So Aeropak recommends that you use JB Weld, because when you put your motor in here and you go to fly, this is where all the heat is. So this is going to get really hot, and a lot of epoxies get soft as they get hot. In fact, I think all of them do. JB Weld softens the least when it gets hot, so it's a great use for that, attaching that retainer onto the motor tube. So JB Weld. I know some people go, oh, well, if JB Weld is good for that, I'm going to use that on the centering rings, I'm going to use it on the fins and so forth. I use JB Weld just on attaching the Aeropak retainer to the motor tube, and then I use normal epoxy, whichever one I'm using, for the rest of the parts. So Kurt, hopefully that answered your question. Let's see. Douglas asks, can you talk about if motor size adapters and motor retainers, i.e. I have a 54 millimeter motor tube, but elect to use a 28 millimeter motor using an adapter, will the 54 motor retainer be too big for the 38 millimeter motor? Okay. So yes, the 54 millimeter motor adapter by itself will be too big for that 38 millimeter motor. It just won't fit. So Aeropak makes adapters that work really well. And basically what the Aeropak adapter does is you take the 38 millimeter motor, it goes into the 54 millimeter adapter, and when you put that into the 54 millimeter motor tube, it makes the 38 millimeter motor look like a 54 millimeter motor to the retainer. So it has a way of capturing the thrust ring. It has a bigger plate that goes over the outside, so that when you screw down your 54 millimeter cap, there's a big washer, essentially looking device that pushes down on the 38 millimeter inside. And so the 38 millimeter motor has been expanded to look to the rocket like a 54 millimeter motor. I use them all the time. They're great to use, easy to use. For some of the smaller motors, 29 to 38, and I think 24 to 29, Mad Cow makes some cheaper adapters, but they're wood and cardboard as opposed to aluminum like what Aeropak makes. Which one you want to use is your choice. So Conway says there are multiple ways to retain minimum diameter. He's done friction fit with tape, retainers like slimline retainers. Aeropak makes a minimum diameter retainer. He uses a forward removable bulk plate. Yeah, in the old days of rocketry, a lot of people used friction fit. I've flown friction fit on occasion when I've had to. I don't like it. I don't recommend it. And the reason why I don't like it is about half the time I do friction fit, and this is me. Other people seem to have great success with it. If you have great success for it, go for it. But me, myself, about half the time I try to use friction fit, I spit the motor out when I fire off the ejection charge and get into problems. So I've stopped doing it just because I can't do it well. But if you can do it well, I would say go for it. And but I know, I think I read something in the NAR or Tripoli handbook that they are now discouraging friction fit as well for the same reasons that I can't make it work. Buyer beware on that. A forward removable bulk plate that mounts with set screws and forward to, yeah. So, yeah, if you can make that forward removable bulk plate with set screws and fasten that to the motor, the motor forward closure, go for it. That sounds like it's a nice do-it-yourself replacement for the Aeropak minimum diameter attachment kind of device. So Conway, I would say, yeah, go for it. Bob says instead of the threaded brass inserts that you see that I have here, he prefers to use T-nuts installed from the back of the centering ring, more surface area, less likely to pull out, and so forth. He hasn't used the brass inserts since he had to retrofit really old rockets for motor retention. Yeah, a T-nut on the backside would work as well or better than these threaded brass inserts. And you're right, because then you're going to have the side of the T-nut up against the wood, so it won't pull through, won't pull out. So that's a good choice as well. But occasionally, or a lot of times, I have people basically get the rocket done, and then they want to figure out how to attach a motor retainer. And these you can install after the rocket is completely built, because you don't need access to the back side of the aft centering ring. You can drill a hole in the aft centering ring and go ahead and go for it. And what I tend to do, I'm paranoid. I will mix up a little bit of epoxy and put a little epoxy down in the hole so that not only is the brass insert screwed in and like a normal screw, but I've got a little epoxy on the threads to help hold it in place. Caution is if you do the epoxy wrong and you get epoxy inside the threaded insert, you're not going to be able to get the bolt in. But Bob, good comment there. Let's see. Slightly off topic, but where did the Mad Cow name come from? My business partner, Mike Stoop, came up with the name Mad Cow 11 years before I got here, and I've asked him about that. And it's an interesting name. When I came along, we had run into mad cow disease in the world, and mad cow seemed like a pretty bad name to use. But it is what it is, and that's who we are. So the name came about when Mike was trying to come up with he wanted a fun name for kids, and he thought Mad Cow sounds kind of fun, and he painted a rocket with the Holstein spots on it. It just seemed like a fun idea. Again, that was before mad cow became a disease in certain parts of the world. But we stay with the name because it's just kind of a fun name. There is an individual I fly with, and he refuses to say mad cow. I guess, I don't know why. I'm not even going to try to guess. But when he's on the microphone being a RSO or the launch safety officer at a rocket launch, he won't say mad cow. He will say angry bovine. So if you prefer angry bovine, go for it. We'll stay with mad cow. But thanks for that, Ronald. So Ariane asks, is friction fitting okay for a plugged motor? I'm going to say it's the same. Yeah, so on a plugged motor, you're not going to have the ejection charge, so you don't have to worry about spitting the motor out the back end. So as long as the friction is good enough to hold the motor in place on the thrust, it should be fine. And I've never had a problem with the thrust side of a friction fit motor, so it's probably okay. But I think NAR would still prefer a more active retention than friction fitting. But yeah, I think that would probably make it a little bit safer, because you're not counting on the motor getting the ejection chart, the nose cone off. And if the friction fit fails on the thrust, it's probably going to fail on the pad, so you're not going to gain any altitude. So it's probably going to be relatively safe from a participant point of view. Although if your motor is friction fit, plugged, and manages to get up inside the further up inside the rocket, it might light it on fire. So, but if you can do it, go for it. But it's probably safer with a plug motor than a non-plug motor. All right. Do I have any experience using window screen retaining clips as motor retainers? Alan asked this. I don't have any experience using window screen retaining clips. I can imagine that they would work. I have seen rockets. If you remember the old beverage cans, they had the pull tabs. I have seen people use the pull tab for motor retention, and so I would imagine that it would work an awful lot like a window screen. And that sounds like a really cheap way of doing it. I imagine window screen retaining clips are pretty cheap, so that would be a nice way of getting there. Thank you, Alan. Thomas asks, single-use composite motors typically do not have a thrust ring. Treat these as one would a low-power motor that is installed a thrust ring, or are there other techniques? Yeah, single-use composite motors, some of them don't have thrust rings, in which case you have to, well, I won't say you have to, because I've seen a lot of creative people in this hobby. But I would advise you to treat it like you would a regular kind of motor, so with a thrust block and an engine hook to hold it. But other techniques, one that I did, I was trying to fly a motor, and I don't remember where it came from. It, like this one, did not have a thrust ring, and my rocket was set up to capture a thrust ring using an Aeropak retainer. So I spent a few minutes looking at that, and what I wound up doing was taking a bunch of tape and wrapping it around the aft end of the engine to make essentially a thrust ring, and then I was able to get that down into the motor tube and capture it, and that worked okay. But yeah, I'm not sure what I would do in that case. Maybe take if I had more time. I mean, I did this out on the flight line. I didn't have a whole lot of time, but if I had time in my shop, what I might do is get a centering ring that would fit for my motor tube, and epoxy a centering ring onto the end of the motor, and then machine it down somehow so that it was then about the size of a thrust ring, so that it would fit properly. There's probably other ideas. I don't know. Over in the chat, people might be giving me better answers than I am. I don't run into single-use composite motors that do not have a thrust ring very often. But the best way is probably to treat them as a low-power motor, or treat them as a low-power motor with a thrust block and an engine hook, or other device, or all of a sudden I lost my train of thought, or figure out how to adapt the thrust ring onto it. Okay, if you're adding epoxy, grease the insert inside first. Oh, that's a good idea. So Bob was commenting on my idea of putting epoxy onto the threads or down into the hole before inserting the threaded insert. And by the way, I didn't mention this, and I should take the time to do that. The threaded insert, if you can see, it has a hex nut Allen wrench driver for screwing it down in. And he suggests if you're going to add a little epoxy to try to hold this in place, the best thing you can do is put grease down in the hole so that the epoxy doesn't get up into the threads, and that will allow you to put the bolt in. So Bob, that's a great suggestion. Thanks for saying that. I'm going to try that next time. Dan asks, are you also making the Polecat rocket kits? We did acquire the Polecat business. We have been having problems with some suppliers, but we think we've resolved it. I don't know that we wanted to make this public, but we have just in the past couple of weeks sold the Polecat rocket business to one of the suppliers, and we're helping them come online. So I expect that Polecat will be available again soon. And Polecat is a great rocket kit. And hopefully the supplier knows what they're doing and how to make the parts better than we did. So I think that Polecat may be coming online a little bit better here real soon. So thank you for that question, Dan. What are retainer options for high power two-staging? Would you just use two Aeropak Mad Cow retainers? Have you seen or heard of any specific interesting designs? I have not done a two-stage. So Douglas asked this. I have not flown a two-stage rocket yet. It's on my bucket list. But what I've seen, or what I understand, the easiest way to do it, the best way to do it is, so the first stage is standard rocket. I would throw an Aeropak retainer on there, no problem. When you get to the second stage, you start getting a little bit more complex. So you're on the second stage, your centering ring is going to have to be far enough up so that you can get a coupler in behind it. So you have a coupler sticking out of the top of the first stage up into the second stage. And if you're, depending upon the size, if you're doing like a 38 millimeter second stage and a 4-inch airframe, it's real easy to put an Aeropak retainer on the end of the motor tube and have it sit down inside that coupler in flight. But if you start getting them real close in size, then you might have to do something like a minimum diameter retainer on that second stage, just because you don't have the physical room in the airframe to have the motor and the retainer and the coupler and everything kind of all pushed together. But I would, or, if you've got the room, the Mad Cow retainer would work. So the retainer is usually not an issue if you have the room in that second stage. If you don't have the room, then you're going minimum diameter and all of those minimum diameter things. But I would suggest that if you are going to try to do a two-stage flight, make sure you have an altimeter that can understand understands the timing, so that if you get horizontal, or even you've reached apogee and you're coming down, at that point you don't want to be firing off that second stage. So you want to have some sort of attitude sensor before you fire off that second stage, and make sure that the first stage actually fired. Getting the two stages separated, that's another challenge. Some people have just used air drag. So they push with the first stage, the motor burns out, and air drag just kind of causes everything to separate. But even if it doesn't separate, the other thing to consider is when the motor in the second stage fires and all of that thrust, all those exhaust gases go down, it's probably going to push off the first stage anyway. So you'd want to think about how you get the stages separated, and then just the mechanical clearances to get everything together. So hopefully, Douglas, that has been answered. I've had luck cutting a motor mount tube into 1/4-inch lengths and gluing one on the end of black powder motor to allow capture with a screw-on retainer. That is a great solution as well. just use a motor mount tube and cut it into a small length and glue it onto the motor. That's probably about the best solution. And I like that one better than the center rings because it's going to be about the right size. Okay, I don't see any more questions. I see people saying hi in the chat. And I believe my time is up. Oh, one more question. Let's say you have a 2.6 kit that has a 54 millimeter motor mount, so it's pretty close, 2.2 to 2.6. The rings are very thin, and the space between the motor tube and the body tube is small. So which kind would you recommend if you don't want the retainer sticking outside in width? It's too, so the Mad Cow won't work in that small of a space because you need the room for the ears. If you don't want it sticking out, then probably a minimum diameter, or what I normally do is I put the centering ring on and I put the adapter on and I just let it stick out the back end of the rocket, and I like that. I could try recessing the centering ring up a little bit more than I did, but then you start running into the fins. So yeah, it's tough. Probably a minimum diameter, or maybe a slim line would work, or friction fit. Jeff, you said thank you. I say you're welcome. Okay, I think I've covered all the questions, and I believe my time is up. So I will thank you for joining me. And again, my name is Michael Klett. I'm with Mad Cow Rocketry. And I know we have a lot of great competitors out there. So I won't discourage you from buying them, but hopefully you'll buy from Mad Cow as well. We think we have some great kits, and I look forward to seeing all of you on the flight line one of these days. I'd like to tell our customers, when I'm talking to a customer, I feel like I'm talking to a friend because I fly rockets and I'm shoulder to shoulder with them on the flight line. So hopefully everybody has been satisfied with my presentations. Thomas, you're welcome. David, you're welcome. Somebody asked, could I recommend a kit? A lot of thanks and you're welcomes. Mad Cow kit for someone going for L1. I like a 4-inch cardboard kit, Stephen. And you probably want to put a 38 or a 54 millimeter motor with a 38 or 54 millimeter motor. 38 is easier for a level 1. But my advice is on a cert flight, low and slow. So go the biggest rocket with the smallest motor. Low and slow is your friend. And after you get that flight out of the way and get your certification, then you can start going high and fast as you want. So any of the 4-inch kits with a 38 millimeter motor mount would work. And a lot of it is your preference. I like short, stubby, fat rockets. My son likes tall, skinny rockets. I want my flights to be as slow as I can get away with because I like to watch them go up. And my son likes to use the really fast motors. And when his rockets go up, they're sitting on the pad. They push the go button, and then the rocket's just not there. You don't even see it go. So everybody has their preference. So whatever you like. All right, with that, I will go ahead and stop broadcasting. Bye-bye, everyone. Thanks for joining me at this year's virtual NARCON.